Algebra 2, Lesson 25, Monomial Factoring, Cancellation, and Parallel Lines. So we'll start off with the monomial factoring and the cancellation. We're going straight to our practice problems. We're going to be doing A, B, and D today. I'm skipping C because we've been doing a lot of those in the past, and it's not too hard to figure it out on your own, but D might be a little more difficult for you. So we'll be starting with practice A, factoring monomials. So, by factoring monomial, what they mean is we want to factor a single polynomial out of this, we want to factor a single monomial out of this group of polynomials. The way we do that is what other math books or maybe previous classes might have called finding the greatest common factor. And that's essentially what we're going to do. We break up the problem between whole numbers and unknown variables, and we're going to find the greatest common factor. So when we look at the whole numbers of 2, 6, and 8, we can quickly see the greatest common factor is going to be 2. So we pull 2 out. Now we're going to go to our variables, and we're going to take them each individually. So I like to work in alphabetical order, so I'll start with m. In the first term we have m squared. In the second term we have m cubed. And in the third term we have m squared again. So what we do is we take the highest common exponent, which in this case the highest common exponent is m squared, because this has m2, this has m2, and this has a little more than m2, but there's definitely an m2 in there. So we take the lowest common one. Now if one of the terms did not have an m, I would not be able to add m in there, but thankfully they all have an m. So I'm going to use m squared. Then I go to the x's. I've got x1, x2, x1. Again, the highest common number they have is x1, or x to the power of 1. Then we go to the y's. y5, y1, y1. Again, 1. So y1. So that's going to be our monomial that we're going to factor out. Now the question is, when I take this out, what does it have to multiply by to recreate this number? So we don't want to change the number, we just want to rewrite the number. We're learning how to rewrite this polynomial when we factor out the greatest common factor, or the monomial. So if I were to divide this numerator by this, if I took 8 and divided by 2, I would get 4 left over. If I took m squared divided by m squared, I would have 1 left over. X divided by x would be 1 left over. So no m, no x. Y5 divided by y, I'm left with y4. Right, and so I'm done with the first term. Now I put the plus sign, and I go to the next term. 6 divided by 2 gives me 3. M3 divided by m2 gives me m. x2 divided by x1, I still have an x. And then y divided by y is 1, so there's no y there. Next, I put the minus sign, and then 2 divided by 2 is just 1, so I don't have a coefficient. M2 divided by m2 is also 1. X divided by x is 1, and then y divided by y is 1. So if they all cancel out, I can't just put 0. In this case, I'm just going to put the whole number 1, because it all equaled 1. And that is my final answer. Next, let's go to simplify. This is kind of the same thing. Now, the most common mistake, people will look at this and immediately they'll want to cancel this and this and then say the answer is 4m5. Absolutely wrong. Do not do that at all, ever. Just don't even. All right. So what we're going to do is we're going to factor the numerator. If you look at the numerator, if I put my hand over the denominator, I look at the numerator, I've got the exact same problem I had up here, but easier. So I look at this and I can tell that the greatest common denominator or factor is going to be m squared. I can take m squared out of both of those and then rewrite the polynomial. Now if I divide 4m to the 5th divided by m squared, I get 4m cubed. And then m squared divided by m squared is just 1, so I put plus 1. And all of that is over m squared. Now I can cancel. The reason why I couldn't cancel before is because this is a polynomial. Right? These are being added, they're not being multiplied. However, this term and this term are being multiplied. So I can cancel. These two will cancel out, and my final answer is just 4m cubed plus 1. All right, now the last problem concerning parallel lines. So practice D gives us this shape. They don't tell us anything about the relationship of these angles, and then we have to use proportions to solve for m and n. Well, the cool thing about parallel lines is that they create what's called alternate interior angles. We should have talked about this already. And if we extend the lines as they pass through and make these intersections, and then if we were to rotate our problem and look at it in this light, we would see that this angle and this angle are alternate interior angles and are therefore equal. And the same is true for this angle. and this angle. So we've got angle, angle, which means these two triangles are similar. Now we can go ahead and start working with our proportions. So when we look at the similar angles, we'll see that 4:7 is going to be our base ratio, right? So those are our whole numbers. That's the one we're going to be using in relation to the sides m and n. So I'll go ahead and draw that twice. We'll use the first one and we'll solve for m. So 4:7 as m:6. Cross multiply to solve. 7m equals 24. M equals 24/7. All right, now, same thing with n. 4:7 is as 3:n. So 3:n cross multiply. We get 4n equals 21. Divide by 4. And n equals 21/4. So our final answer is m equals 24/7 and n equals 21/4.